Assalamu alaikum. My name is Jweria Azhar, a student of MS Chemistry, Batch 4, and my presentation topic is synthetic lubricants for motors, vehicles, their chemistry, and their working. And my this presentation is presented to Dr. Hammad Majeed, HOD of Chemistry Department, UMT Sialkot. And now I will move towards my presentation topic, that is synthetic lubricants. Before discussing synthetic lubricants, I will want to discuss about the lubricants. Lubricants are the chemicals or the fluids that are present or added to the machines to reduce the friction and to reduce the wear and tear of the parts. And these are some lubricants are naturally provided, but these are not much efficient. To enhance their efficiency and their working, some additives are added into synthetic lubricants, and now these are called as synthetic oils or man-made lubricants, specifically engineered to provide the exceptional performance and lubrication properties to various types of machinery, including motor vehicles, and these are basically designed to exceed the abilities of conventional mineral based lubricants. Synthetic lubricants widely used in various industries, including automobiles, aerospace, and manufacturing and engineering industries. These are widely used in the machinery parts to reduce the friction, and my topic is about their chemistry and their working and their applications and advantages, extra etc. Now firstly I will discuss about the chemistry of lubricants. Lubricants are mainly, these are obtained from the petroleum. Their natural source is the petroleum. Petroleum means mineral oil which is extracted from inside of the earth. In the mineral oil, refining removes many of the least desirable components. By the fractional distillation, we will remove the least desirable components from the mineral oil, and these are petrol, gasoline, etc. And their paraffins and acyclic aromatic compounds left behind. These are our main discussion point for the lubricants. And now these are the lubricants, and 80 to 90% of the petroleum hydrocarbons, and then we will add about 10 to 20% of additives to these mineral oils to impart the specific properties. The petroleum hydrocarbon distillation generally consists of paraffins or naphthalenic compounds. And now we will discuss the chemistry of synthetic lubricants. In synthetic lubricants, main point is the base oil, and second is the additives. Base oil means the part of the lubricant which is about 80 to 90%, and these are mostly petroleum hydrocarbons and are the derivatives of the petroleum hydrocarbons. Typical used base oils are the PAO, yani कि poly alpha alpha olefins esters and polyalkylene glycols yani कि PAG. These base oils and size to the processes, these are mainly the polymerization, esterification, resulting in the oils with consistent molecular structure and uniform properties. The chemistry of synthetic lubricants allows for customization based on the specific requirements. First of all, various additives can be incorporated in synthetic base oils, improve their performance in the specific applications. For example, anti-wear additives, friction modifiers, and viscosity index improves can be added to enhance the lubricant's capabilities and capabilities for the automotives and industrial uses. And the second are the base oils. Introduction to the different types of, now we will move towards the base oils. Here the word used is a specific requirement. Specific requirement means on the base of the requirement, a requirement which properties are required for the lubricant. Sometimes the properties that are required are to reduce the friction, and secondly sometimes they just wetting is required, and sometimes we have to reduce the wear and tear of machinery parts. Sometimes we have to reduce thermal stability of the lubricants, and these are all the properties which are required. So for a specific requirement, specific additive is added. Now we will move towards the base oils, their senses and their manufacturing, how these are prepared from the mineral oils. Introduction to the different types of base oils used in synthetic lubricants are PAO, PAD, polyesters, bilobes, silicones, etc. The synthetic processes that can be used for the base oils manufacturing, these are the polymerizations and esterification. Benefits of synthetic base oils consistent molecular structure, uniform properties, If Introduction to the different types of base oils, and there is the PAO manufacturing, and that is the polymerization process. Polymerization, here we use the alkenes will be polymerized and they will form the hydrogen trimers and tetramers. And here we will if these are the ideal, there is the steps that all these polymers should be equal size and equal structures, but actually there is somewhat unevenness, but that can be ignored, and that have effect on the efficiency, but that is not the much higher effect. And synthetic polymers, second are the hydrogenated polydecanes. This is mostly used synthetic polymers. And now we will see that how from the crude oil these are the prepared. Syntheses are usually sourced from the crude oil. Many manufacturing steps results in the high cost. First of all, we have there is the crude oil. First of all, we will done the atmospheric distillation. Then we will go through the catalytic cracking and separation of olefins. All the other unwanted components will be removed from this, and by the catalytic polymerization, ethylene will be obtained. By distillation, we will move towards the 1-decene. Now we have to polymerize these decene, and we will form the polymers of the decene, yani ki polymer of the alkenes will be prepared. Now we have the polydecene, and that is the base oil. Now we will add the additives into them. According to requirement, additives will be added, and now by the additives we have to blend them. And now marketing and synthetic lubricants are ready, and these lubricants will have a high efficiency, high uh, effective work. And now we will move towards some examples of synthetic lubricants. These are the organic esters. Here it is clear that that is the organic ester. Organic, first of all, it is the dibasic ester and polyesters. If we have the synthetic esters as the synthetic polymers, they will have the wide rate temperature range. Wide temperature range means that they can endure the high temperature without changing the much change in the viscosity. And there is much change in the viscosity means they have good thermal stability. There are some in the ordinary polymers, if we increase the temperature by 100 times, their temperature their viscosity will increase by 100 times, but in synthetic polymers there's increase only the 10% by the 100 times increase of the temperature. So that is the temperature range effect of synthetic polymers. No use essentially oil checked. Next, that is the phosphate esters. We will use esters, but the phosphate will link all these esters instead of carbon. They will have high fire resistance. High fire resistance means that they will not catch the fire easily. Used mainly as hydraulic fluids and hydraulic pressures in the hydraulic brakes of systems and the shock absorbers. We use the lubricants. That fluid is filled in the tubules, and that fluid will reduce the frictional effects. Also used as the anti-wear additives by its formation of phospho also used as the anti-wear additives by its formation of the phosphide films are the metal surfaces. And the third examples is the polyglycols. These are the glycols, also called as a POG. These are used in the hydraulic fluids and hydraulic brakes, largest single class of synthetic lubricant bases. And there is the example of them. Fourth one, most important, is the silicate esters. In this, silicon is used, which will connect all the other methyl groups, and these are the good heat exchanger fluids. They have the high thermal stability and high ability to endure the temperature without much change in the viscosity. Now, there are some examples of the addicants for the lubricants, and these includes following general types of additives. Antioxidant. Antioxidant means in simple, when we say that there is the oxidation, we means that addition of oxygen. But in the vehicles, in the fuels, lubricants, oxidation means they will catch fire and they will go through the combustion. Some additives are the antioxidants, means they reduce the ability of the lubricants to catch the fire instantly. And second, they are the rust and corrosion inhibitors. Viscosity index will be improved, and they are the anti-wear agent. Extreme pressure additives, these are the detergents that means they will remove the contaminants and dispersants. And anti-foaming agents, anti-foaming agent means they will reduce the bubble formation, means air and trapping in the additives. And how additives improve the properties of lubricants, there are the many methods. By this, they remove the undesirable they remove the properties Sometimes they add some properties in the lubricants, and sometimes they remove the undesirable properties of the lubricants. By these both processes, they improve the performance and the application of the additives, lubricants. And first of all, they enhance the existing base oil properties. These are the antioxidant, corrosion inhibitors. These are the antifoaming agents and demulsifying agents. All these properties will enhance the existing properties of the base oils. Secondly, they will suppress the undesirable properties of base oils, means they will reduce the pour point, and they will reduce the efficiency. They will improve the efficiency. And third one, they will improve the new properties to the base oils, means these are the additives, detergents, and deactivators and tachiness agents. Are Sometimes they remove the undesirable contaminants and the some agents that can react with the lubricants. And thirdly, now we will move to the working mechanism of the synthetic lubricants, means how they work and how they are, we can say that how they improve the properties of the lubricants. First of all, they film formation. What is meant by the film formation? Synthetic lubricants form a protective film between the moving parts of the machine. Now it is clear that upper and lower are the moving parts of the machine, and between them there is a thin layer of the lubricants. And stable molecular structures and uniformity of the synthetic base oils, they ensure the continuous lubrication and reduce the metal to metal contact. When the metal to metal contact is reduced, they will reduce the direct cold wedge content. We can say that they reduce the friction. And reduce friction and the wear. Explanation of the reduced friction coefficient in synthetic lubricants: smoother surface interaction due to the low viscosity and uniform molecular structure. Role in the reducing the wear and extending the life of the engines and machineries. And third one is they control the temperature and heat dissipation. Temperature control means they will not allow, when the moving parts move, the kinetic energy convert to the heat energy, but they absorb these heat energy and not allow the moving parts of the machine to get heat up. And we can say that excellent thermal conductivity and heat dissipation properties prevent the overheating and maintain the optimal operating temperatures. General rule of thumb for the silicone oil is that it expands by approximately 10% the 100 degrees Celsius increase. Note that this relationship can vary depending on the temperature and particular thermal fluid and used. Lubricating oils forms a film between the surface of the moving parts, and each other, so that it minimizes direct contact between them. This lubricating film decreases the friction, wear, and production of excessive heat between the moving parts. Fourth, we can say that is an antioxidant and anti-corrosion. Synthetic lubricant is resistant to oxidation and degradation, and they added the antioxidant to improve to prevent the formation of the harmful radicals, protection against the corrosion, and prolonged lifespan of the equipments. Fifth one is degeneracy and disperency. Enhanced detergency properties of synthetic lubricants, they keep the engine clean, and deposits and contaminants are the removed. Disperency in the preventing sludge and varnishing formation. We have observed that sometimes they are the black colored oil which is used in the bikes, and that have to be changed by time. The function of that oil is to clean the machinery or the moving parts of the bike. That is the redundancy and disperency of the lubricating, and that is the lubricant. That black oil is the lubricant. And seal compatibility and the leakage prevention, that is the sixth one. And compatibility with various types of seals and gaskets, reduced seal swelling or shrinking due to synthetic lubricants, minimize the leakage and ensuring the efficient operations. Now there is the last and most important part of their efficiencies are the working. That is the uniform composition. That is the main part that will provide why the synthetic lubricants are more efficient and more workable. How they improve the efficiency of the working, that is their uniform composition. From this, we have seen that the upper is the mineral oil. The molecules are the uneven, some are small, some are the big, but in the lower layer all the molecules are of equal size. Equal size means they will form the uniform film. That uniform film will provide that enhanced properties. Synthetic lubricants are engineered from artificially built chemical compounds. Furthermore, synthetic compounds are made from petroleum molecules which are first broken, and then these are rebuilding. These rebuilding will allow the molecules, the formation of the equal sized molecules, and these regular equal sized molecules provide the enhanced efficiency. 7 is the environmental benefits: lower volatility and reduced evaporation of synthetic lubricants. They improve the fuel efficiency and reduce the emissions, contribution to the environment sustainability, and they are the biodegradable. That is the main benefit. Synthetic lubricants can be degraded by the biological agents, means these are the environmental friendly. And now we will move to the advantages of the synthetic lubricants. There is increased efficiency. We have studied that they have low friction coefficient, reduced energy consumption, increased fuel efficiency, minimize the mechanical wear and tear, leading to the longer equipment life. Third, they have improved performance. Improved performance means there is the offer superior viscosity at both high and low temperatures, maintain their effectiveness over the wide range of temperature that improve their performance. Third ones, their engine protection. These are the antioxidant additives are added. They have low thermal breakdown, thermal stability, and they have the preventing agents from metal to metal contact, and by all this they will reduce the engine wear. Fourth is extended oil change intervals, have a longer service life compared to the conventional oils, reducing the maintenance and cost and downtimes, resist the degradation and maintain their performance characteristics even after the extended use. And all these properties will are the main cause for the improved efficiency of the engines. Now we will move toward the application of synthetic lubricants. First half of our application is the automotive industries, common use in the transmissions, differential, power steering systems, and they help to enhance the engine efficiency, reduce the friction, improve overall vehicles performance, and by all the above mentioned phenomena. Second, they are used in the aerospace industry. In aerospace industry, they are widely used in the aircraft engines, leading gears, and hydraulic systems. They offer the excellent resistance to the high temperature and provide superior protection in the extreme conditions. And in the third, manufacturing and engineering industries utilize in the various manufacturing processes as the metalworking, machining, and high-speed applications. They reduce the tool wear, provide the better surface finishes, and improve the overall operational efficiency. Fourth, they provide the renewable energy, play a crucial role in the wind turbines, solar panels, and other renewable energy systems. They help to minimize the mechanical losses, increase the energy capture, and they ensure the reliable operations. And all these are and all this about my presentations, and I have tried to discuss it all the in a better way. And now any questions that can be asked, and thank you for